Okay guys, we're going to start section 8.3 about compound interest, but I do want to remind you that there is going to be a formula sheet provided for your test. I've posted that in Canvas underneath our chapter 8 module. So far, in the first couple of sections, we've already covered all the formulas on the front page. So now that we've covered those formulas, it's all great and dandy, but you need to make sure that you know how to use those formulas, right? So make sure that you're comfortable using that formula sheet. If I were you, I would print that out. I would use that formula sheet as you're working through the notes and the homework so that you're comfortable with where all the formulas are and what they're used for. Okay, so we are at the back side of that formula sheet now. We're in section 8.3 and we're going to talk about compound interest. We talked about simple interest in the last section where that was interest calculated on just the principal amount. But compound interest is a little bit different. Compound interest is interest that's computed on the original amount as well as any accumulated interest. So you put in $1,000 into your account, you get interest on that at the end of, let's say, 6 months. Well, at the end of those 6 months, you now not only get interest on your $1,000, but you get interest on any of the interest that you earn in that first 6 months. So it kind of accumulates, which is pretty cool. So there is a separate formula for compound interest versus simple interest. In this green box, the first formula that we have is for calculating compound interest if it is paid once a year. So if your interest is calculated at the end of the year, this is the formula that you're going to use. So again, just like before, the A stands for your future value, how much you're going to have at the end total. Your P is your principal amount, your R is your interest rate, and your T is your time in years. Okay, so let's use that formula and let's do a few examples here. Example number 1 says that we have deposited $2,000 in a savings account at Hometown Bank, which has a rate of 6%. It asks us in part A to find the amount A of money in your account after 3 years if it's subject to compound interest. Okay, so it's asking us to find the future value. So we know that it's a future value formula. It's saying that I have compound interest. So that tells me that I'm going to use the formula that we just discussed for compound interest and future value. So let's plug in the information that we know from the problem. We know that the principal amount is $2,000. We know that the interest rate is 6%, but remember we're going to put that as a decimal instead of a percentage, so 0.06. And it says in the problem that we're going to keep it in the account for 3 years, so my time would be 3. Now all we have to do is punch in our calculator the correct way. And so I'm going to do inside the parentheses first, I'm going to do 1 plus 0.06. I'm going to raise it to the third power, and then I'm going to multiply my answer by 2,000. So I actually have a calculator downloaded. Let's see if this works. So I'm going to take the 1 plus 0.06 equals, I'm going to raise it to, and so my calculator has an X to the Y button, X to the Y, or maybe you have a caret on your calculator. But I'm going to raise it to the third power, push equals, and then I'm going to multiply my answer by 2,000. And so I ended up getting 2,382. And if this is money, then we should be rounding to 2 decimal places. So I'm going to say at the end of the 3 years, we're going to end up having $2,382.03. $2,382.03 at the end of those 3 years. That's the ending amount total. That includes the original amount of the 2,000 that I put in, plus any interest. So if you look at part B asks us then, what was the interest that we did earn? So in order to figure out the interest that we earned, we're going to take our future value, our ending amount. We're going to subtract out how much we originally put in the account, which is $2,000. And so that tells us that we earned $382.03 in just interest. That's pretty good. Almost $400 in interest as long as we put that money in the account and leave it alone for 3 years. Okay? All right. What happens though if our interest is not calculated only once a year? Because a lot of time, or I guess not a lot of times, but in some banks, they calculate interest multiple times a year. And so we need a different formula to calculate interest if it's a compound interest, if it's calculated more than once a year. So it looks like this. This should also be on your formula sheet. So find it now in your formula sheet so you're comfortable with where it's at. This will give us the amount of money we have in our account if we have compound interest and it's paid a certain number of times a year. So P is the principal amount, R is still the interest rate, T is still time in years, but the N represents how many times a year is your interest being calculated. So if I said it's calculated annually, then that's really just once a year. If I said semi-annually, that's twice a year. If I said biannually, that's also twice a year. Oops. If I said quarterly, then that's 4 times a year. If I said monthly, that's 12 times a year. If I said weekly, remember that there is 52 weeks in a year, so weekly would be 52 times a year. And daily, we could say is 365 times a year. So make sure you know what those words mean so you can use the correct value when putting it into your formula. So let's do a problem here. It says on example number 2 that you deposit $7,500 in a savings account that has a rate of 6%. The interest is compounded monthly. So it says here keywords, right, that we have to look for. We have compound interest. We have our interest rate of 6%. We're compounding it monthly, and then we're going to put in $7,500 into our account. Okay, so a couple keywords that we have to look for to decide what formula we're going to use. So that's kind of the difficult part about this assessment is there's a lot of different formulas and we have to make sure that we're using the right one. So in order to do that, we've got to look for those keywords. So I know it's compound interest. I know it's calculated more than once a year. It's doing it monthly. So I have to use the formula that we just talked about up above. Remember it was this one, A equals P times 1 plus R over N to the NT power. Now let's plug in our information. So we know we have a principal amount of $7,500. We have an interest rate of 6%, but remember we're going to put that in as a decimal, so 0.06. We know that we're going to calculate, or the bank is going to calculate our interest monthly. So our N, how many times a year is it going to be calculated? Well, monthly means it's going to do it 12 times a year, every month. That goes on the denominator, and it goes in there as my exponent as well. And it says for how many years are we going to keep it in the account? It says how much money will you have in your account after 5 years? So I'm going to then also multiply that 12 by 5. Okay, so here's the hardest part is we have to now make sure that we put it in the calculator the correct way. So instead of doing 12 times 5 in my exponent, because I want to be careful in my calculator, instead of doing 12 times 5 separately, I'm going to actually off to the side calculate what 12 times 5 is. And instead of saying 12 times 5, I'm going to put a 60 up there. Okay, so now this is the hard part of putting it in our calculator the right way. Are you ready? So here we go. We're going to do inside our parentheses first. And so I'm going to do parentheses 1 plus 0.06 divided by 12 and my parentheses. I'm going to raise it to the 60th power and I'm going to push equals. But then I still have to take that and multiply it by 7,500. And you should get $10,116. And again, if this were money, we're going to round it to 2 decimal places. So that would be what, 38 cents? Make sure you can use your calculator and punch it in correctly in the correct order so you have that same number as I do. I know all of our calculators are a little bit different, so you might need to play around a little bit to make sure that you know how to use your calculator properly, but it's important that you know how to enter this in your calculator so you get the right answer. So again, $10,116.38 would be the amount of money that we have in our account after 5 years. So what did we start off with? It looks like we started off by putting in $7,500, right? And so if we put in $7,500 at the beginning and we ended with $10,116.38, how much interest did we earn in those 5 years? And could I find the difference? Could I take the $10,116.38 and subtract the $7,500 from it? And so at the end of 5 years, by just putting that money in the account, how much money extra did you just earn in interest? I ended up getting $2,616.38 in just interest. Pretty cool, huh? All right, I'll stop it for now, let you practice those examples.